Today, we're embarking on a deep dive into the very fabric of our financial Java software. When you're writing Java code that handles billions of dollars in live stock market data, you need to know your Java software architecture down to the exact byte, so we're going to unpack the why and the how behind using Java's core data types. Today we'll start with the Java foundation and variables, then scale our way up from Java primitive types to using reference data types in memory, and finish off with some enterprise coding tips. Section 1, Java Foundation and Variables. The Java programming language is a statically typed language. This means every single piece of stock market data, whether that's a stock price or a company name, the value being stored must have its exact data type declared before the Java code can be compiled. So this means we cannot have a Java program where a text string accidentally tries to act like a stock price. That strictness is exactly why Wall Street apps rely so heavily on Java to manage stocks trading transactions. Java can catch programmatic calculation errors before the software even runs. Now, to store all the data related to stocks information, we use something called a variable. A Java variable is essentially a reserved memory space in a computer. To save a stock in the memory of a Java program, the stock symbol is the variable name, and the stock price is the value stored inside the memory box. And before you can put a value into that memory box, you must specify exactly what shape and size that memory box needs to be. Section 2, Primitive Types. We go from small to large memory-sized data types. We scale memory from 1 bit all the way to 64 bits. We're going to walk through Java's primitive data types sequentially, going strictly from the absolute smallest memory-sized data type to the largest. Primitive values are the fundamental building blocks of every Java software program. Java primitive data values are stored directly inside a memory container called the variable. The Java Boolean data type. For storing the smallest data values, we use the Boolean variable data type. A Boolean value represents just a 1 bit of information in the Java program's memory. A Boolean variable can store only a simple value of either true or false. For example, a Boolean value stores the stock market status. The isMarketOpen variable value can be set to true or false. The Java byte and short data types. Next up, we have the byte variable data type, which takes up exactly 8 bits of memory space. After that, we have the data type short, which takes up 16 bits of memory space. The data types byte and short are used to store some of the smallest integer values. If the number values are much bigger, then we would have to use the double data type or the BigDecimal data type for mathematical calculations in a banking mobile application. Next up, we have the 16-bit char data type. This char data type can hold a single Unicode character as the value. It is incredibly lightweight and super fast. We don't want to waste precious memory space to store the entire words buy and sell. This is absolutely perfect for storing the stock order type of buy, using the letter B, or sell, using the letter S. The int and float data types. Now we are stepping into the 32-bit territory, where we can use the data types int and float. The int data type is perfect for storing whole numbers up to about 2.1 billion. For a stocks trading application, a 32-bit int variable is perfect for storing things like daily trading volume or total share counts for your average size companies. The next data type is the float. It can store up to 32 bits of data, which handles basic decimal numbers. But we have to be careful here, because the float data type completely lacks the deep decimal precision that we need for performing serious financial calculations. It's okay to use float numbers for estimated values, but the float data type simply cannot handle the exactness required for storing sensitive US dollar amounts in a banking or stocks trading application. Long and double. Finally, we reach our 64-bit heavyweights. First is the long data type, which we use for massive whole numbers that blow right past that 2.1 billion limit of the int data type. Think about modern giant companies like Apple and Nvidia. If you try to calculate their total market capitalization with a standard int value, the number would be so big it will overflow and crash your entire Java program. Using a 64-bit long data type instead of an int is much better in this case. Then we have the 64-bit double data type. This double data type can hold numbers with multiple values to the right side of the decimal. The double data type is the standard for calculating exact stock prices, stock price moving averages, and percentage dividend yields. It gives us a wide range of values with deep precision to the right side of the decimal. But these double data type values have some serious limitations. Welcome to Section 3, Reference Types and Memory. It is time to move from the stack memory to the heap memory. So up until now, the Java primitive data types we just covered, they store their exact values directly inside the primitive variable. But now we transition to something a bit more complex and talk about using reference types. This fundamentally changes how our system interacts with the computer's memory. Reference data types are incredibly fast, but using reference variables, we don't store the data value. Instead, they only store an address on the stack object. That address then redirects the computer to read the object value located in a much larger memory space called the heap, where the complex Java object is located. Reference types use up more memory and introduce a tiny bit of access overhead. A perfect everyday example of a reference type is the string. Now, a string value is a text value. A string is not a primitive data value. A string is a complex object in Java. For example, a string value can contain the text for a long ebook with many pages of text. In a stocks trading app, a string can be used to store a full company name like Nvidia Corporation, or a stock ticker symbol like Nvidia. Because a string is a complex data object, it absolutely requires the Java variable to store an address in the variable, and then redirect the Java program to read the complex object located in the destination memory address. Finally, Section 4, Practical Coding and Enterprise Tips. Let's uncover that Wall Street secret. Knowing the theory is one thing, but I have to make sure you're writing Java code that will actually pass a rigorous enterprise code review on Wall Street. Creating these variables in your Java code is a strict two-step process. Declaration. Step 1 is to declare the Java variable. This is where you set the type and the name of the variable. For example, writing double current stock price followed by a semicolon. This essentially tells the computer to build the physical variable memory box to store the value. Initialization. Step 2 is initialization. This is where we assign the actual value to the new variable that was created, like current stock price equals 150.25. This is the act of actually putting the stock price value inside the box. Remember, you cannot use a variable until it has been properly declared and initialized. Let's also talk about professional naming conventions. In Java, we should always use what is called camel case lettering when creating a new variable, starting with a lowercase letter and then capitalizing the first letter of each subsequent word. Naming a variable current stock price is infinitely better than just throwing in a vague letter P. Think about it. If a fellow engineer is reading your code at 3 a.m. during a massive market crash, current stock price tells them exactly what that data is, but the variable name of P tells them absolutely nothing, and it can be difficult to understand what is the meaning of P. In the beginning, we talked about using a 64-bit primitive double variable to store a stock price, but in reality, professional financial applications avoid using double variables entirely. Why should we do this? Because a double variable value is based on floating point arithmetic, which is the computer estimating fractions using base 2 binary mathematical calculations. And this estimated value normally creates a floating point rounding error. So we should only use Java's true enterprise standard reference data type called BigDecimal to store US dollar amounts in a banking application. Because if we were to calculate these cash flows using a primitive double value, then it would get the output value of $10,612.24. But the correctly calculated result is actually $11,412.28, not $10,612.24. Using the double value means we miscalculated almost $800 simply due to the binary rounding limitations of the double data type. A single rounding error like that, scaled across millions of stock trades, can cost a company a financial loss of millions of dollars. This means we should always use the BigDecimal data type to store monetary values. This gives us arbitrary precision, eliminating those double data type floating point errors entirely. So, let's wrap up today's video. I want you to think really hard about the Java code that you wrote in your software application. Is your financial software application using a double data type to store and process bank account transaction money values? Now you have gained a solid understanding of Java data types. Thank you for watching this video. I hope you liked this video. Please subscribe to this channel to see more videos that are just like this one. I have been working as a senior software engineer for more than 10 years, creating professional database and web software applications. If you have any questions related to computer programming and job search, I can be available to help you as your career coach. I have been helping people to prepare for the programming job interviews and job search. Please read the description in this video for my website and contact information. Thank you and see you next time.